All right, so here is a quick review of ways to factor. Kind of broke it down into the ways that I would have taught this during algebra. The first way is to undistribute. Basically, you can do this with any amount of terms. And this is the first way that you should try to factor any and every problem from here on out. Okay, so undistributing to me is just taking out a common term. And when we say we're taking it out, we're going to find that common term and then divide it by every single term in the problem. So, for instance, this is only a binomial because it has two terms. If it would have 5 terms, we would do it to all 5 terms. All right, so again, I'm looking at this. I'm trying to find the biggest number, the biggest letter that I can take out of everything. So if I look at 32 and 24, I'm going to say that I can take an 8 out of both of those. And from there then, if you wanted to, you could go back and you could put 8 underneath of these. And so you're showing yourself that you're going to divide. So if we divide this, then we would have 4a squared. And over here we would have 3k squared. And whatever you take out goes on the outside of the parentheses. Everything else just stays on the inside of the parentheses. And the last thing you should look at is, did I get everything that I could possibly get out of it? So if I look at my numbers, 4 and 3 obviously don't have a common term, and the letters are different. So I might have to do it more than once. Okay, so again, this is something that you should try every single time with every single problem. The next way is factoring by grouping. This is usually with 4 terms. We'll actually use this method over here with the trinomials though. But if you have 4 terms, the first thing that I should do is look to undistribute again. And then after that, we'll show you what to do. So in this case right here, if I try to undistribute, I can undistribute 2 out of everything because everything's an even number. So that's the first thing I'm going to do. So again, I'm going to divide each of those by 2 as I'm dividing, or as I'm going through my parentheses, okay? And we end up with our 4 terms again. So even though that you did something in the previous step, you still got to see if you can do more. And so after you take out your common term, then I'm going to come back and I'm going to factor by grouping. So one of the things that you can't forget about is this number that you already dealt with. Don't forget that. That's got to end up in my answer at the bottom. So when we're factoring by grouping, I'm going to take the first 2 terms and the last 2 terms, and I'm going to group them together. Okay? Sometimes you might have to rearrange the terms, meaning write them in a different order. Sometimes you just do it as they're given to you. From here, then, you're going to basically undistribute each of those set of parentheses. So in this first one, I'm going to take out my common term. Again, I'm just looking at the 2 terms, though, now. So here I could take out 2k. If I take 2k out of the first one, I end up with just a k. And over here, 6 divided by 2 is 3. Don't forget to bring down the sign. And then the k's cancel each other out. If you notice in my second parentheses, in this case right here, I didn't take anything out. But there's always a 1 out here. So essentially, I'm going to say plus 1 is what I took out. And then I'm just going to rewrite whatever is in my parentheses. This is kind of a special case. Most of the time, you would do the exact same thing that you did in the first set of parentheses. You would take something out, and that would be a different number, term, whatever you're talking about. But in this case, it was already as simple as we can get. But you have to show that you took out a 1. Now, every time that you do factor by grouping, or sorry, not every time, but just about every time, your parentheses should end up showing the exact same thing inside the parentheses. That's going to be one of your answers. So I'm going to write that term that's inside the parentheses down, and then whatever we took out is going to make up the next part of my answer. So the 2 came all the way down from the beginning that we undistributed from the beginning, and then the like parentheses makes 1 parentheses, and what we factored out makes our second parentheses. Okay? The other thing that we should probably talk about here before we go any further, remember, anytime that you have exponent of 2, or whatever your exponent, biggest exponent is at the beginning of your polynomial, that tells you how many answers you should get. So answers meaning how many sets of parentheses I should get, or how many answers that I could come up with. And so we would talk about solving these after we would actually figure out how to factor them. Okay? So we move on to trinomials. Again, trinomials just simply means that there's 3 terms. Here, there's kind of 2 basic ones, meaning is when we do trinomials, you always want to write them in descending order, where the biggest term, meaning the biggest exponent, always comes first, and the number that's all by itself would come last. And then what I would do for these, I'm going to make 2 sets of parentheses, and I'm going to kind of do this at the same time because I want to show you the difference between the 2 problems. So from here then, I always want, after I write it in descending order, I always want to make sure that that first term is positive, so I don't really think about the sign of that term because I know it's positive. So I'm going to look at the second sign that I can see. Notice in this top one it's negative and the bottom one it's positive. This is going to tell me what my signs are going to be inside my parentheses. So if it's a negative sign, that automatically tells me the signs that go inside my parentheses is 1 plus and 1 minus. If the sign is positive, okay, that tells me that my signs are going to be the same, and they're going to be the same as this first sign. So in this case right here, because it's positive, that tells me these have to be the same, and they're going to be the same as the first sign. From there then, basically, I'm going to split up whatever my first term is. In this case, it was y. In this case down here, it's a z. And then I have to think about if I have different signs, and I'm going to add things together, I actually subtract them. If I have the same signs, I'm going to add them together. So, what are the factors of 60? Again, what does factors mean? It means the numbers that are being multiplied together. So what factors of 60 that I can subtract, because I have different signs, give me 4. So again, if you don't know them, you got to just start listing them. 1 times 60, 2 times 30, 3 times 20, 4 times 15. And we're looking for 4, right? 5 times, 12? 6 times 10. There we go. If I subtract those 2 numbers right there, I get my 4. So I know that 6 and 10 have to go into my blanks, but now I have to decide which one goes in which blank. This is where you look at the bigger of the 2 terms, and the bigger of the 2 terms has to have the same sign as your first sign. So because we want a positive 4, 10 has to be positive, and my 6 would be negative. So if you think about it, how we can check all these problems with trinomials is, if I do FOIL to this, my parentheses, I should get my original problem. But if you think about like terms, what's positive 10y minus 6y? That's where I get my 4y. So it looks like we did it right. Down here, same principles, but because the sign was plus and my 2 negatives are in the problem, 2 negatives, when we're adding, would make another negative. So we're adding the factors of 30 that make up 11, and hopefully you can see that that's 6 and 5. And then we're done. Okay? So those are a little bit more simple just because they don't have a term or a number, coefficient out in front of those variables. This one over here is a little different because it does have a number out in front of your first variable. So this is process where we're going to bring back into the grouping into our solving of a trinomial. So when you do this, the first thing that you're going to do, you're going to take and multiply the first term or coefficient times the last term. So I'm going to do 10 times 20, which gets me 200. okay? Basically now what you're going to do is you're going to try to decide what would my signs be in my final answer. I should have one positive and one negative because the second sign is negative. So what are the factors of 200 that I can subtract and get 17? So this one you might have to do a little work with, okay? So we start listing them. 1 times 200, 2 times 100, 3 probably doesn't work, 4 times what, 50? 6, 7, 8. 8 looks like it works. 8 into 16 is what? 12? No, it's way more than that. 8 into 20 is 1. 2, which is 16, so 25, 8 quarters and $2. If I subtract those two, that's what we want right there, okay? 25 minus 8 is 17. All right, so we found our factors. Now this is where you gotta adjust a little bit. When there's a problem like this, you're gonna bring down your first term every single time. You're gonna bring down your last term every single time. And then each of these factors that you figured out are going to get a variable. Okay, so go back and put a variable with whatever group of factors you decided on. And now you have to think about the signs of these two numbers. Well, again, the bigger number always has to match the sign in the problem. So I'm going to make this a positive 25 and this a negative 8. From there, then, you can group these with whatever one that you want down here. It does not matter where you put it. It should work out every single time, no matter what decision you make. So I'm going to put 8D with my 10, and remember, it's negative. And then I'm going to put positive 25D with my negative 20. From here, then, we're right back to what we did at the beginning with the factor by grouping. So I come, put parentheses around the first two, put parentheses around the last two, and now I undistribute the biggest thing that I can from both. So what can I take out of both 10 and 8? And a D. If I divide, 10 divided by 2 is 5, D squared divided by D. Then over here, we're going to take negative 8 divided by 2, and my D's cancel each other out. From there, then, we try to do the same thing. So this is a better example than the one that we had over here, or just what you would actually do here. So what can I take out of both of these? I'm going to take out a positive 5. And so 25 divided by 5 is 5D. Notice again. And then negative 20 divided by 5 is negative 4. So again, notice my two sets of parentheses are the exact same thing. That's one of my answers. And then my other answer is what we took out from the common terms. And we get our answer. Okay. Last but not least is doing the difference of perfect squares. So when we say the word difference, we always mean that it's a subtraction problem. And then perfect squares we talked about before. Remember, anything that is a perfect square, I can take the square root of it without getting a decimal for my answer. So difference of perfect squares, if you recognize that they're perfect squares, these are pretty easy. You make your two sets of parentheses. You always have one plus and one minus, always, okay? Because remember, if I do FOIL to this, I get back to my original problem. And if I have different signs, I'm going to subtract. Well, in the subtraction of difference of perfect squares, my terms cancel each other out. So, again, to make this really simple, I take my first term and basically take the square root of it. So what's 121? The square root of 121 is 11. And the square root of m squared would be m. That is going to go before the sign in both sets of parentheses. Then I'm going to do the exact same thing over here. What's the square root of 144? Square root of p squared. And so I end up. So again, if you did FOIL to this, notice 11m times 11m is 121m squared. My inside terms and outside terms, they're the exact same thing, but they have different signs. That's why they cancel out and there's nothing there. And then my last terms If I take positive 12 times negative 12, I get 144 on the p-squared. All right, so again, these are things that you might want to actually go back and look at from time to time. So feel free to use that anytime that you need a little brush up on factoring. If you have any questions, come see me.